Alright, let's try to solve the fourth illustrative problem. I think this is the last problem. Alright, so this would be the last video for this particular topic. Okay, where is it? Alright, there it is. Okay, number 4. A barge floating in fresh water has the form of parallelepiped having dimensions 10 meters by 30 meters by 3 meters. It weighs 4,500 kilonewtons when loaded, with the center of gravity along its vertical axis 40 meters from the bottom. Find the metacentric height about its longest and shortest center line and determine whether or not the barge is stable. Again, barges, just like scows, are used as temporary, how do you call that? Placement. I don't know. It is where cargoes from ships are temporarily placed may mga container vans or mga cargo, no? So, nilalagay temporarily. Ayan. So, let's try to analyze both sides, the long and the short sides. So, let's try first to analyze the longest center line, the long side of the barge. So solve for the value of the draft from the principle of So the first, so we're to solve for the metacentric height and determine whether it is stable or not. So solve natin basically yung MBO and GBO, compare the two. Then from there we identify whether it's stable or unstable, and then from the two also we solve for the metacentric height. Okay, so first we need to solve for the draft. Ito yung figure natin. Ito yung the long side, the 30 meters yung width niya along the long side. So hindi given yung draft, so we solve for the draft by the principle of buoyancy. So equate lang natin yung buoyant force and weight since they are equal. And then, given naman yung weight ng barge and the load or the cargo. So, yung cargo plus yung barge, it weighs 4,500 kilonewtons. Equate natin yan sa value ng buoyant force, which is equal to gamma of water times displaced volume. Displaced volume would be in terms of D. So 30, kasi yung figure natin, 30 times D times yung length niya perpendicular to the screen, that is actually 10 meters. So the draft is 1.529 meters. And then from there, we can now solve for the location of the center of buoyancy. So basically, the center of buoyancy is just located D over 2 from the bottom or D over 2 from the liquid surface. Okay, so solve natin yung GBO. We usually solve it by inspection. So ito yung G is 4 meters, located 4 meters from the bottom of the barge. So 4 meters. Yan siya. So marami sigurong laman itong barge. That's why medyo mataas yung location ng center of gravity. So 4 meters minus D over 2, that is actually GBO. That is 3.2355 meters. So yan yung GBO natin. And we solve for MBO using our formula exclusive for rectangular section. There's no angle of tilt, so theta is 0. So B squared, ang B natin dito is 30. 12 times the draft was solved a while ago, that is equivalent to 1.529 meters divided by 2. So that's GBO. I mean, ito pala. So, MBO. So, MBO is 49.052. So, definitely higher, than the center of gravity. Napakataas. So, very stable yung barge natin in terms of the long side of the barge. Okay? So, stable siya. So, and then we solve for mg by inspection ulit. So, by inspection, what is mg? Distance between the metacenter and the center of gravity. So, basically, it's equal to mbo minus gbo. So, mbo minus gbo, that is actually mg 45.8165 meters. So, safe siya sa may center line. Ang mg safe along the longest center line or the long side, and mg niya sa long side is 45.8165 meters. Okay, now let's consider yung shortest center line, the short side of the barge. So ang width natin B is 10 meters. Ayan. So same pa rin yung location ng center of gravity, 4 meters above the liquid surface. I mean, from the bottom of the barge. And then, the draft, of course, is the same. Yung sinulong kanina na draft, yung draft dyan, parehas lang naman sa draft niya kapag sa may short side. So, although the solution will still be here, so parehas lang sila ng draft. The same solution, And then, center of buoyancy, of course, is located still the same. That's d over 2 from the bottom of the barge. So by inspection, we solve for GBO. It's equivalent to 4 meters minus d over 2. So we have a value of GBO equal to 3.2355 meters. Ayan. Then solve for MBO. Mag-iiba dito would be the value of B. Of course, theta would still be 0. There's no angle of tilt. So MBO is equal to 5.45450 meters. So B now is 10. Kanina 30 meters yan. Ito naging 10 meters na lang siya. So MBO is 5.450. Still greater than GBO na 3.2355 meters. So it's still stable along the short center line. So, stable pa rin siya. So, safe against rolling. Then, by inspection, we solve for mg since MBO is greater than GBO. So, we solve for mg by subtracting itong dalawa. MBO, that's 5.450 meters minus 3.2355 meters. We have an mg along short center line equivalent to 2.2145 meters. So, yan yung metacentric height natin along short center line. So, safe for both sides, long and short sides. Okay, so that's it. So, I hope the videos somehow help you understand the topic. Okay, so until the next video then. Okay, so thank you very much.